The first step to producing our composite model is to export the individual model files into file types supported by the Composite Model viewing and analysis software, in our case, Navisworks Manage. Let's step through the simple steps for exporting files from Revit environments into common file types such as CAD DWGs, IFCs, and native NWC files. We'll start with an NWC. Let's navigate to a 3D view of the architectural shell model. Revit offers a free add-in tool called Navisworks Export Utility, which will convert the RVT file into an NWC file. From the Add-ins tab, choose External Tools and click Navisworks 2011. Enter the Navisworks settings and make sure the box Convert Element Properties is checked, since this will ensure that we don't just get a limited set of properties. There are other settings under Model Performance that allow enabling compression of geometry. Be careful with this because you might lose model geometry if this is enabled. Also in snapping, under the Interface branch, we can make sure that snapping to vertex and edges are checked, which affects how we will be able to navigate and manipulate the model later in Navisworks. Click Save to export. We get an error message, but it seems rather minor since it only concerns a mullion. Let's choose to ignore this for now. Now let's export the structural model. After opening the model, let's navigate to a 3D view, and this time go to the main drop-down menu and choose Export, selecting IFC. All we need to do now is to save it. We'll do similarly to export the MEP HVC model, but this time to a DWG CAD file. From the main menu, choose Export and select AutoCAD to choose DWG DXF. Once in the dialog, change the export setting to In-Session View and choose All Views and Sheets in the model. This generates a list where we can check those we want to export. Check to include the 3D view. Click on the DWG Properties tab where we will change the coordinate system basis to be shared, which ensures the model coordinates get read in Navisworks and thus ensures the alignment with the other models. Give it a meaningful name and save. From within an empty Navisworks file, we can now begin to aggregate the different model parts. First, we should confirm that the global option settings suit our project needs. On the Tools menu, click Global Options. Expand the Interface node in the Options Editor dialog box and click Display Units. Choose the linear units from the list, changing from meters to feet and inches. We can also check that our viewpoint default settings and our model performance are set accurately. Now let's begin opening our individual model files into this single viewing environment of Navisworks Manage. First, we will open the architectural model. Next, we can append the MEP HVAC WG file. And finally, we can append the structural model, which is an IFC. Now we'll need to perform a transform to bring the structural model into alignment. We can accomplish this in one of two ways, either by repositioning by snapping or through manually entering the offset in each of the XYZ directions. Let's first look at the snapping mode. We will need to find a common vertex as a point of reference to snap the structural model to the architectural model. On the architectural model, we left retaining walls which are identical and congruent geometry to those of the structural retaining wall. So we are going to match up these two corners of the retaining walls to align the entire models. In the Measure drop-down, select Point to Point. Now select the bottom outer corner of the retaining wall in the structural model, which gives us a 3-axis icon. Next, click again on the same point in the architectural model, which will draw a line between these 2 points. Then, from the Review tab, in the pull-down menu, select Transform Selected Items, which results in the model being transformed in space from the first point to the second point. Then, with a clear command, we can erase that measurement. Now let's try transforming manually. Select the file in the selection tree, then in Item Tools tab, First click Move, then click Transform to activate the pull-down. We'll enter -35 for the X and -10 for the Y offset. We'd imagine that we'd already measured these distances in the model to determine those exact offsets. Now we have a composite model of our architectural, structural, and HVAC models. This is the beginning, and later we can add others such as our lighting and plumbing model. Now let's look at how we might save this composite model. Go to File, Save As, and save as Composite Model NWF. NWF files are very useful formats because no geometry is saved, but rather a list of the appended files along with their path relative to the NWF file is saved, along with any overrides, comments, viewpoints, and other Navisworks specific information. This is our master NWF project file, which references the latest model files that we just brought into this environment. With the refresh command, the software will reload any model file that has been changed since the last load. Here's the scene view of our entire model, and in the selection tree we see the different individual models that are now united in the scene view. Navis has countless navigation tools for investigating and exploring the composite model. We can use the View Cube, a 3D navigational tool that enables us to reorient the view of a model by clicking predefined areas on the cube. It allows us to quickly control the camera angle and is especially handy for achieving elevation or plan views. On the navigation bar, let's go to the full navigation wheel, which unites all tools in one spot. We can orbit, we can pan, we can zoom, and here also on the navigation bar we can walk. As we drag our mouse down, we can lower ourselves. The look around tool allows us to pivot to change the angle of the camera. As we click our mouse and slowly move it forward, that'll engage walking forward. And we can turn to face the door. We can pass through the walls or doors to get inside and look at the interior of a space. Again, I'll use the Look Around tool to change my direction. When we click the center mouse button or the wheel and move the mouse up the screen, that'll float us up so we can go to another floor. And by combining these tools and with some practice, we can navigate anywhere in the building to achieve a multitude of perspectives. Just like video games, navigating 3D models requires a certain amount of hand-eye coordination that simply comes with practice. Another simple way to explore the model is through the selection tree. Now that we've brought in various models, let's examine further to see how they interact and relate. From the selection tree, I can highlight and right-click to hide or require any of the models, or even the model components. And as I expand the hierarchy, I can drill down to a component level. In most cases, my components are organized by level. And don't worry that some are lacking a level assignment, since their position in 3D space is still understood. I can click individual components and they'll be highlighted in scene view. This is very similar to our project browser in Revit, since it allows us to navigate the project by individual model, by level, or by individual elements. And we can see the element names as they were imported. So by using my different navigation tools in conjunction with the section tree, I can examine how the different discipline models are interacting to check for any large errors or larger issues. Another very effective tool is the 3D sectioning. If we go to the Viewpoint tab, we can check Enable Sectioning, which brings us to a Sectioning Tools tab. There are two modes of sectioning, both by plane or by box. Right now, in the plane mode, I can select any one of the 6 planes with which to cut the model. By mousing over the gizmo, I can pull and push the plane to get the desired view. Let's try the section box mode. We have the ability to move the box any direction by pulling the grips, or we can scale it, which means to change the width between any two of the opposite planes. Mousing over one of the grips, I can push or pull in order to stretch, in order to make wider or more narrow the box in any one of the 3 directions. And in this way we can create even the most narrow cross sections of the model, which could be very helpful in isolating very specific regions of the design. Also, we're able to rotate the section box or section planes using the rotate command. This enables a gizmo with controls for rotating. In this way we can create some very complicated sectioning geometry. Viewpoints are an important feature of Navisworks. They not only allow us to save and return to views of the model, which are of importance, but they can also be used for design review audit trails and for setting up model animations. Viewpoints can optionally retain saved attributes as well, no matter the changes we make in the course of navigating, so that on returning to a viewpoint, the camera angles, sections, overrides, and hidden items are reinstated. Let's make our first viewpoint, which will be the result of using a slanted section plane to get a terraced cutaway of the building. From the home, choose Save Viewpoint, and we'll give it a meaningful name. Within the Save Viewpoints window, we can rearrange the viewpoint hierarchy, add or delete files and folders, rename views and folders, update viewpoints to save the current scene view settings, and override any old settings. We can also change whether it's a perspective or orthogonal view. Let's go ahead and create and save viewpoints of interest by combining different camera angles, cutting sections, and or hiding or requiring elements or whole categories of elements. Let's make some viewpoints that isolate out one or a couple of disciplines, and we can also arrange them into meaningful folders. Here I'll create a combination of structural MEP. And here, a simple structural framing and here a plumbing model. All these saved viewpoints can facilitate our work later on as we recall these views in the service of our design review. Here we can take a bird's eye view of the restroom area, and we can include that into a folder titled Plumbing. We've already looked at using camera angles and hiding in order to manipulate views, but let's take a look at how we could add color overrides to add emphasis. Here in the retail space, we can notice that the ducts are interfering with the beams. Let's save a viewpoint that highlights this. From the selection tree, let's highlight all the level 1 lights and change them to a blue color. Similarly, let's select the beam and all its matching geometry and change them to a red color. Finally, I'll make one last override to the flex duct, making that a pink color. And with these three simple overrides, we've immediately called attention to these three components so that a designer can quickly see the issue. Now let's create another viewpoint where we use the section box to isolate out just the plenum space above an office. And in that viewpoint, we'll use some color overrides to emphasize the components of interest. Here we will demonstrate how to create intelligent sets of like objects in the composite model, with which it will be easier to review and visualize our project. Selection sets are useful for saving a group of items that we might want to regularly perform some action on, such as hiding or changing transparency. Selection sets simply store a group of items for later retrieval. If the model changes at all, the same items will be selected when recalling the selection set. That is, there is no intelligence behind this kind of set. Let's go to the selection tree and hold Shift or Control to select many rows at once in the tree. We'll open the Sets window and right-click in the space to choose Add Current Selection, and we'll name this Concrete Framing. Let's make a selection set as well for foundation elements. Another more powerful way to create sets is to use the Find Items tool to search or query for items having a common property or combination of properties in the model database. Search sets work in a similar way to selection sets, except that they are intelligent in that they save search criteria instead of the results of a selection so that we can rerun the search at a later date as and when the model changes. From the category drop-down, select Item. A common property to search on is the name, but there are many other options as seen here. From the property drop-down, select Name. From the conditions, we'll select Contains, meaning we are not looking for an exact match, in which case we would have selected Equals, but instead any name containing concrete. In the Value field, type Concrete. Click Find All to perform the search. In the Scene area, all the items satisfying the search condition will be selected and highlighted. We should also look around the building to check that all the concrete members we had been searching for were selected. In that way, we know our search was successful. We'll right-click and choose Add Current Search. We can name this All Concrete. Let's perform a search for glazing or windows and add that set called Glazing Panels. From the selection tree, we see that the mullions are going by a name including the word rectangular. What if we use that keyword in a Find Item search and then add that as a search set? titled mullions. We can then organize these sets into their own folders once we start getting longer lists of sets. Suppose we wanted to merge the mullions and glazing into one combined set. Let's see how we could do that. First, we can copy this glazing set from the shortcut menu. Let's rename it accordingly. Then we'll select the two sets by holding the Control key so that they are being selected in the scene view. Then right-click the glazing panel's copy and choose Update the selection to include all the elements now selected. And there we have created a set that is the amalgamation of the two. In fact, we could have accomplished that set of glazing and mullions in one simple step using Find Items. So from this scene, let's search on both keywords at once, glazing and rectangular. We'll do this by choosing the OR condition option. With those items now automatically found in the project database and highlighted in the scene view, we can save them to a search set. Notice that the glazing from the double doors on the first floor have not been selected. To include those double door glazing panels, we would even need to refine our criteria further by adding yet another keyword. And as you can see, we can leverage the Find Items tool to quickly organize our model into meaningful sets.